A warm welcome to all who are watching this video. Hope you are having a nice day. In this video, I am going to discuss the concept of renal clearance. Renal clearance is defined as the virtual volume of plasma which is cleared of a substance by the kidneys in unit time. What does this phrase virtual volume mean? For a minute, instead of considering plasma as a fluid, let us consider plasma as a train of carriages. There are many a number of carriages, a finite number of carriages which are connected to each other, and all these carriages are filled with various substances. And let's assume that all these carriages are filled with various substances. Amongst them, there is one substance called X. X. Now, clearance refers to the number of such carriages from which X is emptied out by the kidney in unit time. The number of such carriages from which the X is emptied out by the kidney in unit time. Because we cannot define a virtual volume of plasma as such. Whatever substance is present, it is present in the distributed in the entire volume of plasma. We are assuming we are figuratively compartmentalizing the plasma into various carriages and thinking that this much amount of carriages and this much amount of volume is being cleared off that substance X by the kidney in unit time, and that is the clearance of substance X. Now, to determine or to measure the clearance of any substance, we follow the principle of law of conservation of mass, which says that if there is a substance X which was there in the plasma in certain quantity, and if it gets transferred into urine, its quantity in the urine and its quantity in the plasma should remain the same because mass is neither created nor destroyed. Now, let us have a few abbreviations. Px stands for the plasma concentration of X. Any substance X, it can be measured. If the substance is detectable, identifiable, you can just take a venous blood sample of the plasma and then you can determine the plasma concentration of that substance. Cx stands for the clearance of X, which essentially means the volume of plasma in which X is distributed. So if we take a product of Px and Cx, we get a net amount of substance which was present in the plasma, in that virtual volume of plasma, which is going to be excreted out in the urine. So thereby the product Px and Cx should exactly be the amount of that substance present in the urine. Now let's come to Ux, which is the urinary concentration of the substance X, and V dot, which is the urine formed in unit time. Ux, the product of Ux and V dot stands for the amount of that substance excreted out in the urine per unit time. So Px and Cx stands for the amount of that substance present in the plasma, the virtual volume of plasma we are concerned about in unit time. And Ux and V dot stands for the amount of that substance excreted out in the urine in unit time. And by the law of conservation of mass, these two should be equal. So if we write down the equation, it stands something like Px into Cx is equal to Ux into V. And thereby, clearance of X is equal to urinary concentration of X into rate of flow of urine or formation of urine per unit time by plasma concentration of X. You can measure the plasma concentration of the substance, you can measure the urinary concentration of the substance, you can measure the urine formed in unit time as well. So if we get all the values of all these three variables, we get the value of clearance for a substance. Now, what is the practical implication of clearance? Why do we want to know that? Now, think of it for 1 minute that for a substance to be transferred either from plasma to urine or for a substance to be exchanged between plasma and urine or plasma and glomerular filtrate, there are only three ways. Either the substance is to be filtered out through the glomerulus, or it is to be secreted in the tubule by the cells from the peritubular capillaries, or it is to be reabsorbed from the tubule. These are the three ways there can be an exchange between plasma and filtrate or urine. Now think of a substance which is only way it is transferred from plasma to urine is through glomerular filtration. That is, whatever amount of plasma reaches glomerulus, that and only that plasma is cleared of that substance. So clearance of that substance, let us name that substance A, will reflect the amount of plasma reaching or getting filtered by the glomerulus per unit time. So that clearance of A, if we write it as Ca, will be equal to nothing but the glomerular filtration rate. And there are two such substances. One is an exogenous substance called inulin, and the other one is an endogenous substance called creatinine. We can use both to measure the glomerular filtration rate of a substance. There are pros and cons of using each of them. We are not going into that detail. Coming to another applied part of this clearance, let us assume a substance, let's name it B, and this is one such substance which is filtered by the glomerulus as well as secreted by the tubule and not cleared off. So virtually whatever amount of plasma reaches the kidney is cleared off of the substance B in unit time. Now, what is the total amount of plasma reaching the kidney in unit time? The renal plasma flow. So clearance of B will reflect the renal plasma flow. And if we know the renal plasma flow, we can also know the renal blood flow. We can just divide the renal plasma flow by 1 minus hematocrit, HCP stands for hematocrit, and we will get the renal blood flow. Another important parameter for the kidney, which we can assess from measuring clearance of a substance. Now, one such substance which is used to measure the renal plasma flow, that is, it is filtered and secreted, but not reabsorbed, is called PAH, which stands for para amino hippuric acid. So this is how we can utilize the concept of clearance into measuring clinically significant renal parameters. So clearance is the virtual volume of plasma cleared of a substance by the kidneys in unit time. We know that we use the principle of law of conservation of mass to determine it. And now we know that we can use various clearance of various substances depending on how they are transferred from the plasma to kidney, by what route, to determine the glomerular filtration rate and or the renal plasma flow and thereby the renal blood. With this, I end my discussion. Thank you very much for listening.